Welcome to the final video in this risk management tutorial series. In this video, we will be discussing the use of expected value of trades as a means of analyzing your trade positions in order to help manage risk better. To start with, what do we mean by an expected value? As the name suggests, expected value is the carefully calculated, educated estimate of the value of any object based on its careful analysis. In statistics, expected value represents the average value of any variable, any random variable, in the long run. That is, it is the mean value that would be obtained from an infinite number of observations. The expected value is found by multiplying each numerical outcome by its probability and then summing up all the possible outcomes. In finance, however, it is the product of the anticipated value of a financial instrument, denoted as X, with the probability of getting the same anticipated value as an outcome. Expected value is denoted as EX, where X is the random variable, which is the financial asset in consideration in our case. So EX becomes the expected value of the financial instrument in consideration, and this EX is equal to the product of X times PX, where PX is the probability of getting the value as X. So why do we really need to calculate the expected value of a trade and get into all the details? Expected value of a trade, or any trade system for that matter, helps in evaluating the profitability of your trading system or your trade strategy. It helps a trader to calculate and understand the risks involved in his strategy so that he can prepare himself well enough in terms of the capital required to carry on his strategy. It is a means which helps you to analyze how much you can expect to make on an average by using your trade system or your trade strategy, and therefore helps get an estimate whether the trader would be profitable in the long run using his trade system. The bottom line of using expected value of trades is that it considers trading as a probability game in order to determine the odds that are in favor to earn profits through that trade system. Let's consider an example to help understand this concept better. We consider the probability game of rolling a die for which you pay $1 to play. The rules are that you win $3 each time you roll an odd number, that is 1, 3, or 5. However, you make nothing at all if you roll an even number, that is 2, 4, or 6. Therefore, the probability of you winning is 3 out of 6 outcomes, that is 3 over 6, or 0.5. While the probability of losing also is 3 over 6, that is 0.5. So you have 50% chances of either winning or losing. Let X be the variable that represents the profit earned when you get an odd number. So the value of X is $3, while Y is the profit that you earn when you get an even number, which is 0 as you earn nothing when you roll an even number. Here X and Y are both independent variables, as the value of one does not depend on the value of the other. Here Px denotes the probability of getting the value X, which is the profit that you earn when you win. Therefore, Px is equal to 0.5, as we had discussed that the probability of winning or losing is the same as 0.5 in this game. Similarly, Py is the probability of getting the value Y, which is the profit that you earn when you roll out an even number, which is 0. The probability of you not winning, therefore, is Py, which is also equal to 0.5. So using the formula of expected value of X equal to Ex as the product of the value of X with its probability, we get Ex is equal to X times Px. That is x times the probability of getting the value x, which is 3 times, since the value of x is 3, that is the profit you earn on winning, and probability of x, px, is 0.5, so x times px becomes 3 times 0.5, which is 1.5. Therefore, the expected value of getting an outcome x, that is, the expected value of earning a profit of $3 is 1.5, while the expected value of y using the same formula comes out to be y times p of y, where y is the profit you earn when you do not win the game. That is 0. Therefore, expected value of y comes out to be 0. Now, since x and y are two independent variables, hence, as used in statistics, the expected value of the product of two independent variables is the sum of the expected value of those two variables. Using this concept, the expected value of the outcome of this game is equal to EXY, that is the expected value of x times y. Using our statistics, we state the formula EXY is equal to EX plus EY, and then we put in the values that we computed above into this equation to get the result as 1.5. Therefore, the expected value of the outcome of this game is 1.5. This is the profit that you can expect to earn on playing this game forever. Considering that you pay $1 to play this game, your net profit therefore becomes 50 cents. So, to summarize, if you continue playing this game forever, you will always end up making at least a profit of 50 cents, irrespective of whether you have a series of losses or wins together. The net result will be a profit of 50 cents. This is the utility of calculating the expected values of your trading systems to get an estimate of whether you will be profitable in the long run. So just like how we use the concept of expected values for a game, similarly, we can use the same concept to determine the expected value of a profit or the outcome of using a trading strategy or a trade system. As long as the expected value of your trade strategy is positive, you will remain profitable as long as you're in the game. In most cases, it would not matter how many times you win or lose. What matters is how much you win and how much you lose. To determine that, we need to analyze what the expected value of your loss is in case you lose, and what the expected value of the profit is in case you win. And finally, what is the overall expected value of the trade strategy? So we now try to apply that concept of expected value on a trading system. As we discussed, expected value of an independent variable x is defined as a product of the value of x with the probability of getting that value x. Here x is the value of the variable and px is the probability of occurrence of that variable x. While using it to compute the expected value of our trading strategies, we define x as the average profit earned on a winning trade and px as the probability of a winning trade. Similarly, y becomes the average loss incurred on a losing trade. Since it is a loss, we denote y with a negative sign, and p negative y is the probability of a losing trade. Since both x and y are independent events or independent variables, therefore, using the statistics formula, expected value of your trade becomes EXY, just like it was for the expected value of the game in the rolling die example. So EXY is equal to EX plus E of minus Y. When you compute the expected value of a negative variable, the negative sign is pushed out of the brackets and the absolute value of the variable is considered in the formula. So, doing the same, our equation changes to EXY is equal to EX minus EY. Assuming that a trader has an average value of profit on a winning trade of 95 pips and an average value of loss on a losing trade of 55 pips, the value of X becomes the pips earned on a winning trade, which is equal to 95, and Y denotes the pips lost on a losing trade, which is equal to negative 55. These average values over here in this example are completely hypothetical. However, through series of backtesting, a trader can determine his average value of profits or losses on the winning and losing trades respectively in his trading plan. Next, we assume that the probability of a trader being correct is 0.4. That is, the trader is correct in his trading decisions 40% of the times and has 40% of winning trades. Therefore, the probability that the trader goes wrong is 1 minus 0.40, which is 0.6 or 60%. So the probability that a trader is correct on his trade decision and makes a winning trade is 40% or 0.4, and the probability that the trader is wrong on his trade decision and makes a losing trade is 60% or 0.6. Px over here becomes 0.4 and Py becomes 0.6. So now overall we have X is equal to 95, Y is equal to minus 55, Px is equal to 0.4, and Py is equal to 0.6. So we have the values of all these four variables. We only need to put them into the equation we discussed before to calculate the expected value of the trading strategy. To do so, the expected value of a winning trade. This is the product of the value of X times the probability of getting X, which is 95 times 0.4. As a trader makes 95 pips on a winning trade, and he has a probability of 40% of having winning trades, the expected value of a winning trade becomes 95 times 0.4, which comes out to be 38. Using the same principle, the expected value of a losing trade is computed as the product of the value of Y, that is the loss made on a losing trade, which is 55 pips, and the probability of making losing trades, which is 60%. The value comes out to be negative 33. Therefore, the expected value of the overall trade system, denoted by EXY, is equal to EX minus EY using the equation, and that comes out to be 5 pips. So under the given assumptions, with this trade strategy, the trader always is in a net profit of 5 pips. Again, this is just an hypothetical example, and real analysis and real calculations would involve extensive backtesting to determine these expected values. Before concluding this video, there are a few important factors to consider while calculating the expected value of a trading system. Make sure you have backtested and analyzed sufficient amount of past data to determine your estimate of the average profit and loss. Take into consideration the fact that there needs to be enough opportunities available for you to be able to use your trade strategy. Thirdly, make sure that you have the entry and exit points well defined for your trade strategy, as timing is a very important factor in trading. And finally, it is important to note that this methodology is based on the assumption that you believe that the outcome of your trades is relatively certain and predictable as per your expectations that you have computed. Well, this is all that we will be covering on this topic of expected value of trades. Thank you for taking the time to watch this video.